Hi, let's do some classification. I will build a model which classify BBC articles in one of the 5 categories. We'll see here all the steps we're going to do, from getting data, exploring this data, preparing, cleansing, transforming, and preparing for model, then project model, training, and evaluating. The data I used in this presentation are available at this address, so they are public. After getting the data into data frame, you will see that we have 2,225 articles, and each one belongs to one of the 5 categories: sports, technology, business, entertainment, or politics. And as we can see, the distribution of these categories is quite balanced. So we have about 400 to 500 articles in each of them. First of all, we have to do some cleaning data, changing the text into something which will be easy to evaluating by the next steps. So first of all, we have to split text into words and then find the relevant words from these words. I mean, this means you removing all the signs which are not letters or numbers, removing also numbers, and so-called stop words, which are the most popular unrelevant words, such as to, and, I, and so on. After that, I did some insights of the texts, and we will see that we have distribution of lengths of the text. I mean, the number of words in each text, and we see that the most text have about 200 words, but there are some texts, quite a lot of them, which have about 500 of text, but more than 500 it's not popular. So we can think that 100 words in text it's the maximum, and this is very important because it will be important to set up the one of the most important parameters in future. We will see. So we have the proper words, and now we have to do something from these words. We have to change them into numbers, because numbers are the format which is okay for models. First of all, we limit our dictionary to only 2,000 most frequent words, and map them into numbers. Then we define that our vector will have a length of 500. This is this number of words which we saw in the most popular articles. So, and if article has less than 500 words, we have to pass the remaining space with zeros to have the vector of the same size. So we will, in the end, we will have the 500 features as numbers in our data set, and we will have to encode the string labels into numbers as well, and divide our data in 3 sets: training, validation, and test. So in the end we will have 1,601 records in training set, with, of course, 500 features and 1 target label, and 401 records in validation set and 223 records in test set. Of course, the number of features is the same, and the same as the target. So let's build a model. Our model will consist of 3 hidden layers. first is embedding layer, in which we transform our 500 length vector into 64 so-called word vector, which is depending on our text. Then a droplet layer which prevents from overtraining our model. And the third layer is the core layer of our model, which is bidirectional LSTM layer, which means long short-term memory layer. It is a special kind of recurrent layer with memory. So it is very good for sequences data, like for text. And of course, we want to have the output as 5 length vector with probabilities of each category. After training the model during 10 epochs, we see that accuracy is quite okay, and the behavior of the model is very good, which means we can assume that the model is okay, it's not overlearned, and we can evaluate it. So, evaluating model on our test data, and we got these numbers with test score. It's about 17, 0.17, and test accuracy is about 94%, which is quite okay, I think. In confusion matrix, we see that categories such as business and sport and technology also are very good predicted. We see some problems in entertainment politics categories. For instance, we see that 3 sentences which should be technology was assumed as entertainment, and yeah, so we can find the problem here. But generally speaking, the predictions are quite okay. Thank you.